Okay, sorry. So I will tell a little bit about robotic harvesting of fruit vegetables. The main subject is about sweet pepper, but the organizers asked me if I could tell a little bit about other fruits, and that actually is about cucumber, and that was the first project we started with robotics. And of course, I'm not the only person working on this. There are two other names on this sheet, and that were the project leaders. I always have to tell which is funding our research. We do not have our own money, only work on project basis. And it was funded by the national government in the Netherlands, by the growers, and especially by the European Union. I will give a very short introduction, then I will talk about cucumber robot harvesting and up to projects about sweet pepper harvesting. Why robotic harvesting? I think the main issue is that we want, especially in Europe and also in the Netherlands, maintaining a very sophisticated greenhouse horticultural sector, because if we don't have any growers anymore in the Netherlands, also the whole supply industry will get lost, and that's a big business in Europe. Of course, we want always have to have lower labor costs, but even more important that we want to have sustainable labor. The current situation, I think, and that's almost in every country, labor in greenhouse sector is not considered as sustainable. In the Netherlands, there are no Dutch people working on harvesting. They all come from Poland, Romania, Bulgaria, and so on. And that's considered as not sustainable. If we could replace that labor by robots, we will replace the labor by high-skilled labor, because the robots have to be built, have to be maintained, have to be operated. I think also robots will give a better guaranteed food safety. In 2011 in Europe we had the so-called AUSVEG scandal. So the whole selling of cucumbers, tomatoes and sweet pepper dropped down because there was people even died from a bacteria. Finally it was another product who caused it, but it does not matter. And I think robotics can better guarantee this safety. Higher quality, you can selective harvesting, so you can first maybe harvest the highest quality. For instance, there is an example in the Netherlands that the strawberry grower is harvesting very high quality strawberries for the Japanese market. Then you get 10 times the normal price, so a robot could also do that. And I think as last, maybe you can get a higher yield, because now you have to, in your greenhouses, to take care that the climate does not harm human beings. If there are no human beings, you can have a higher temperature, higher humidity, and so on. Actually, already more than 30 years is there robotic harvesting research worldwide, and we made a review article, and I would really advise you to study that. That's also show you what's happening worldwide and also why there is still no robot. Okay, first the cucumber harvest. That was a project finished in 2002, so already more than 10 years ago. But still the results have not been, by other groups, did not receive better results on cucumbers. And it was a national project. Okay, cultivation systems are very important for robotics. You have to consider that. If on the left picture you see the traditional cucumber growing system, and if the plant is growing on a certain height, it reaches a wire, a horizontal wire, then you drop over the plant onto the wire, it grows down to the floor, and maybe you can even go up again. And it's the total mesh. And actually, no robot will ever can handle such a system. At the time we did the research, then also for cucumber, there was a so-called high wire system, like tomatoes. So the plant can become, say, 20 meters or something like that, and you always drop down it. And in a high wire training system, you always pick leaves. Otherwise, it would be a real mess on the floor. And if you would do that, leaf picking before harvesting, you see on the right picture, you get a very open system and it's easily to detect where the fruits are. Now, cucumber harvesting robot, I will not go in too much details, but normally you have a manipulator, you have an interfactor on the manipulator, you have a camera system. Also, normally we need artificial lighting and of course a lot of electronics and computers and so on. And the car is running, and because of the Dutch situation, on the heat pipe rail system in the greenhouse. And on the right you see how it looks like in the greenhouse. Now, the end effector, for every application you need another end effector. That's normally in robotics. And for the cucumber we were motivated by electrosurgery. So we went to a hospital around us and we borrowed a big system what they use for surgery, and we tried it and we rebuilt it. And actually what you get, you actually not cutting but burning, and what you have then no virus transport in the greenhouse, and there will be no mold both on the fruit or on the plant, so that's better. We looked at cucumber, and then the first thing is everything is green. How can you make difference between leaves, fruit and stem? And actually it turned out to be very easy. Don't look at color, but look at water, because the fruit is almost 90% water and so on, and the leaves a little bit less, and the stem even more less. And you see here an example. At the top picture, you see it's all green, and actually, if looking at water, you see we can really distinguish the two fruits in the picture. And the depth, of course, you also need a third dimension. That's used. We used stereo vision. Oh. So now this is a movie about the robot in an experimental greenhouse, but that was a real crop. So we just pushed a button and it started, and what you see here is lightning, because during daytime you have a lot of problems with the sun. So now there is made a picture, then the robot is going to the fruit. And now you see the burning. And there is a kind of suction in order to fix the fruit, and then it's put in a box. It's not too fast. There was a certain reason, because the camera and the robot should not be in the same area. And also the robot is not running too fast due to safety reasons, because all the researchers were all normally very close to the robot. And what you see is the burning is between two electrodes. The electrodes are not cutting or whatever. Okay, this was the cucumbers. What were the results? The detection rate was quite good, 95%. And one of the things is, at that time, if there were two fruits just behind each other, then the detection algorithm saw it as one fruit, so that was not a good detection. The harvesting rate was 74%. It was most of the time a mechanical problem. And the cycle time was almost 2 minutes, and that is a little bit too long. But okay, this was cucumbers. There is a website. You just put in Google a cucumber harvesting robot, you will come to this site, and there is all the information. Then I go to sweet pepper. And there's the first project that was called Crops. That's about harvesting of high-value crops. And the idea was the picture that we had a modular system. Now, there were a lot of partners. I will not mention all of them. There were universities, research institutes. There were companies like C&H Industrial, probably some of you know them, Force A, and also a German company called Vesto. It started in 2010, at the end of 2010, and what ended last year. We had a budget of 10 million euro, and Europe financed this project with 7.5 million euro for this 4 years. And we had 13 partners from 10 countries. This was not only sweet pepper, we also looked at apple harvesting, grape harvesting for premium wines, precision spraying both in orchards as in vineyards, and at obstacle avoidance in forestry. But I will only discuss sweet pepper. Now, about sweet pepper harvesting, this is the growing system. Either the gullies are hanging, in, like this picture, or the gullies are on the floor. And the plants are clipped or twisted along a wire. And we only considered in the project either red sweet pepper or yellow sweet pepper. We do not consider green sweet pepper, although they are also grown, of course. As I told you before, for every application you need different end effectors. We developed two for sweet pepper. On the left, that was designed by the company Festo. And what you see is there are a kind of fingers, called fin ray fingers, that look maybe not so nice, but it's very soft, and they really grip the sweet pepper very well, as you can see in the lower pictures. And in the sweet pepper is cut by a scissor. And also on the end effector there is a camera systems. On the right you see a lip type end effector. We developed that. That does not need such an accurate detection of the position of the fruit. And actually you will see in the movie, it's are two rings and they are closing, and then the sweet pepper is cut down. It's cut from the plant. Now the sensors, again, this is also color cameras, and also for the distance we use the time of flight camera, kind of laser system. And we also used stereo vision for locating the stem. What's very important, what we introduced in this project was at that moment very new. That's the so-called robot operating system, ROS. That means you get a kind of plug-and-play system, and if you change your sensors, you don't have to go very deep into the software, what in the past was a real issue. Now you will see a movie of the sweet pepper harvesting robot. As you can see, there is no space. It's a real mess, and then you have to pick a fruit. First, you have again lightning. And also in this case, you have to take out the lighting system from the working area of the robot. You see here the fin ray type end effector. Actually, Festo now brought his fingers on the market, not for the greenhouse sector, but for the food industry. You see here the second end effector, the lip type. And you see a tube that's for transporting the fruit to the box. And you already can see here that there should be no people quite close to the end effector, what you will now see, because it's quite dangerous. because this was one of the new things. We think that the manipulator should not transport the fruit to a box, because that takes far too much time. I think this was it. The results, the fruit detection was much less than for cucumber, because we had a lot of problems with occlusion of the leaves. So the fruits are behind the leaves or partly behind the leaves, and in sweet pepper it's not allowed to first pick the leaves because you have problems with sunburn. The harvesting success was not so great, but that has a mechanical problem. There is also kind of suction inside the end effector to grip the fruit. And the cycle time was a little better as than for a cucumber. Okay, there is a website where all the movies are on, and also for the other applications you find a lot of information. So then we applied again at the European Union for a new project called Sweeper. We only have now 6 partners, where 3 of them are also from the crops project. And it's very new, that's called the Tuindershoek. That's a commercial sweet pepper grower who is really a research partner in this case. All the experiments will be done in his greenhouse. Now again, some facts. We have a budget of 4.6 million euro. The European Union now gives 4 million euro, and it's for 3 years. And it's now in the what's called the Horizon 2020 program. How is Sweeper working? We will continue using that ROS. It was a success. We will use the lip type end effector so that the mechatronics helps us with the inaccuracy of the detection. We will not use again a sensing system on the main platform. We only will use a sensor on the end effector, so we will use visual surveying. We will do crop adjustment. That's why we have a research station from Belgium in the project. And also, due to the fact that we have a grower as partner, we have a lot of input from the sector. Okay, again, we have a website where all the information will come on. Okay, now this is not... Okay, the other slide was not mentioned to show, and I want to thank you for your attention. Okay.